to our first video, and today we're going to be doing simplification. So the first step of simplification, of normal simplification, we need to understand terms. So let's say we have 2x plus 3 minus 5x minus 1. So we need to know which terms are similar terms, okay, or like terms. Now we can see that 2x and 5x both contain x, while 3 and 1 don't contain any x's. Therefore we can say that x and 2x minus 5x and negative 5x is similar, and then 3 and minus 1 are similar. Now if we were to simplify that, then we were to say that 2x, now we have to add these two, so 2x plus minus 5x, okay, and plus minus 5x is basically just saying minus 5x. 2 minus 5 is equal to negative 3x, okay. Now we have to add positive 3 and negative 1. So we have 3 plus minus 1. Again, we can say those are minus, and then we say 3 minus 1 is 2. So, and it's a positive number still, so we can say that this is equal to negative 3x plus 2. And as you can see, it is much simpler to say this than to say this whole thing again. Next, we'll be saying, okay, let's say that 2x, it was 2x squared, okay, and then it was plus 3 minus 5x plus 1, or negative 1, but in this case we'll have plus 1. So it's the same as we had last time, except that it's negative to the power of positive 2. Yeah, so it's 2x to the power of 2. And this, the power makes these two are not similar. So these two aren't similar anymore. But 3 and 1 are still similar. So then we can still say that 2x squared plus, now we knew that's 2 minus 5x, and it's still okay, but we know these two aren't similar terms. Okay, so then in our next example, we have now the distributive method. So we have 5x plus 3, and then we have brackets. Now to simplify that, we can just say 2 times 5, which is 10x, plus 2 times 3, so we're just timesing it like that, okay. 2 times 3, which is 6. So that is the same. These two are equal. Now it's similar, like it's more simple like this, but I mean, if you want to have it, you can have it like that. But yeah, so these two are equal. Let's say we get now we get this, but then we also get plus 4x minus 9. Now we can see that nothing is timesing into these, okay, so we can just as well say that that these brackets aren't there because they're not useful. So now we can say 2 times 5, so then we still have this 10x plus 6, okay, but now we have this plus 4x minus 9. Now, which ones are like terms? 4x and 10x both contain x, while 6 and minus 9 don't. So those two are similar. So then we can say that 4x plus 10x is 14x, and then plus positive 6 minus 9 is equal to negative 3. Okay, so we basically just added those together, okay, those two similar terms. and then we get this. This is much simpler than what we had in the beginning of this, and it is definitely much simpler than we had over here as well. So as you can see, simplification helps a lot. So now, in our next example, we're going to have multiple variables. So we have x, y plus 2x minus 3x 2y plus 5x. Okay. Now we can say that, now we can see, okay, we must look for like terms. 2x, okay, is similar to 5x because they're like terms because they both contain x, and there's none of them have an extra square. But if this did have an extra square, then obviously it would not be like terms. But now we have xy and 3x 2y, okay, and those are like terms. Okay, so then we can just say that negative 3x minus x is negative 2x, basically. Okay, then 2y, negative 2y would be negative, okay, 2x, and then we have 2y, I think it's plus, so we should add these two, and that makes it 3, because these two could be times together, if they could, because in times then you can have it anywhere around. So then if we have 2y, then it could be 3y. Okay, and then we get plus, okay, plus 2 plus 5, so then we definitely know this is going to be a positive when we add these two, okay? So then positive 2 plus positive 5 is equal to positive 7x, okay? So as you can see, this is also quite a bit simpler than what it is written over here. Okay, so now we're going to go into our next example, which is going to be a very long example. Okay, so we have x squared plus 5xy minus 3x plus 4x squared minus 2xy, and then 2xy plus 5x. So this is quite a long sum, but if you want, you can try and pause the video and do this by yourself. Okay, so hopefully you have done it and gotten it right, or if you haven't done it right now, then it's fine, I'll show you the answer. Okay, so we have x squared, and then we have 4x squared, and those are like terms, okay, and then we have a 5xy and negative 2xy, also like terms, and then we have negative 3x and positive, okay, that's a plus sign, positive 5x, okay. So now x squared, okay, now obviously we can add all these like terms together. Okay, x squared plus 4x squared is 5x squared. Because remember, there's a 1 in front of it. Okay, then we have 5xy minus 2xy. 5 minus 2 is 3, so it's still a positive number, and it's 3xy. Then we can get negative 3x and positive 5x, which is the same as saying 5 minus 3x, which is 2x, positive 2x. Okay, and as you can see, this is way simpler, okay, than that. It's much shorter than this long expression. Okay, so obviously we have done that, and hopefully you have gotten it right. If you haven't, you must make sure, and you can go and maybe rewatch some parts of the video to be able to understand the work better, or go watch other videos out there. Exponents. So we have x squared times x to the power of 3, which is equal to x to the power of 2 plus 3, which is equal to x to the power of 5. then we can say x to time we can say x and then x squared in brackets. Sorry, we can say x squared, okay, to the power of 3, which is equal to x2 times 3, which is equal to x to the power of 6. Okay, and then you can also get x squared divided by x to the power of 3, which is equal to x squared over x to the power of 3, which is equal to x squared, okay, minus 3, which is equal to x to the power of negative 1. Okay, so we have, these are the main exponential laws. So if you have exponents and then times another one, then you say 2 plus x to the power of 2 plus 3, or like whatever the powers are. And if you have them in brackets, so this is okay, then you have 2 times 3, or whatever the exponent or power numbers are. Okay, and then you also have, with the dividing, then you subtract the 2 power numbers. Okay, so now we're gonna have a really long sum, like the one that we had put before, but we're gonna have these exponential laws also going to be needed to simplify it even further. Now we have x, okay, we have 4x squared, okay, plus 2y to the power of 5 minus 3x squared minus 5y to the power of 5, okay, and then that's going to be divided by 2x minus 3y squared, okay, plus x plus y squared, okay. So now we have 2x minus 3y squared plus x plus y squared, okay. So let's first simplify these two expressions, or these two equations, expressions, okay. So we're going to say those are equal to 4, okay, so 4x squared, okay, is a like term with negative 3x squared, which is equal to x squared, because 4 minus 3 is equal to 1. And we don't have to put the 1 there. If you want, you can put the 1 there. Okay, so now we have 2y to the power of 5 minus 1y, because there's an imaginary 1 there, to the power of 5, which means 2 minus 1 is 1. Okay, so we have positive y to the power of 5 over, and we have 2x plus x, that makes it 3x, okay, and then we have negative 3y plus y squared plus y squared, which is negative 3 is the same as saying, okay, negative 3 plus 1 is the same as saying 1 minus 3, which is equal to negative 2y squared. Now we can say, because there's imaginary ones here, so we can say that these, now we divide this, okay, obviously you can't divide that, so we just leave it in a fraction. So we have 1 over 3, okay, so 1/3, and it's a times x. Now x to the power of 2, okay, so then it's actually x 2 minus 1, okay, okay, so now we say 2, so it's still a minus 1 over 2, so it's a half, okay, and then we have this times y to the power of 5 minus 2, which would be equaling to 1/3 times x, okay, to the power of 1, so we don't even have to put that 1 there, okay, minus 1 to the power half times, okay, times y minus 2, which is equal to y to the power of 3. So this is so much simpler than saying this whole expression up here, okay? There's like the whole expression up here, okay? So it's so much simpler, okay? So now we can say, we can revise what we've all learned today. We have learned that like terms you can add. So 2x plus 3 minus 5x minus 1. So these two can add and these two can add, making that this is negative 3x plus 2. Okay? Then we also learned that if this x were a square, these two terms would not be like terms, and thus we wouldn't be able to get this answer. Okay? The distributive method of simplifying 5x plus 3, so we can just simplify that to 10x plus 6, which is a much easier version of reading than saying that. Okay. With the exponential laws, we said that exponent times an exponent, then we say 2 times 3, or 2 plus 3, so then we'd get 5x, so these two would plus. And if it were in brackets, then these two would times, and then we'd get to the power of 6. And if they were in, like, divided, so like that, then we'd say these two minus, and then that will be equaling to x to the power of minus 1. So that's all we'll basically learn today. Yeah, okay. So I hope you enjoyed the video and you were able to understand the exponents and like the laws of exponents and the simplifying them, and also simplifying normal expressions and stuff like that, and that you now understand how to determine like terms. So when writing the test, you should always go and check out and underline or mark each like term, and then make sure you add up the like terms correctly. Okay, see you in the next video.